Hey guys, and welcome back to another video on the channel. In today's video we're going to be looking at arithmetic sequences. Now, we've pretty much looked at sequences before, but we haven't taken a look at arithmetic before. So a sequence is pretty much a pattern of numbers. So for example, you might have heard of the Fibonacci sequence, where it's just a pattern of numbers pretty much. An arithmetic sequence is pretty much a sequence where it's increasing or decreasing by a constant amount. So for example, 1, 2, 3, 4, that's an arithmetic sequence because it's increasing by a constant amount. So you see it's just increasing by +1, +1, and then +1. So an arithmetic sequence means it's either increasing or decreasing by a constant amount. This is also an arithmetic sequence. 2, 4, 6, 8. Instead, it's going by +2. But you can also have it going in the opposite direction. Now, it doesn't have to be positive numbers as well. So, for example, it could be like, let's say, all right, a half. Then it's 1. Then it's 3 on 2. Then we can see pretty much the pattern. It's increasing by a half. Yeah, it could also be going backwards as well. So, for example, if it was going, let's say, 0, negative a half, negative 1, it's decreasing by minus a half each time. So that is pretty much an arithmetic sequence. So a sequence is a pattern of numbers. An arithmetic sequence pretty much means it's increasing or decreasing by a constant amount. Let's see what we have here. A sequence in which a successful term is found by adding a fixed amount to the previous term is called an arithmetic sequence. That's pretty much what I've just said. They've just put it in fancy words. That is, an arithmetic sequence has a recurrence relation in the form of this. Alright, so let's break down what this actually means. So t of n equals t of n minus 1 plus d. So t of n means a term in the sequence pretty much. So for example, this I could call is my first term. So this would be t of 1. And I'll call this my second term t of 2. That's pretty much what it means. So t of n is like a general expression. So t of n has to be pretty much an integer, because you can't have t of a half pretty much. You can't have half a term pretty much. Otherwise it would be a different sequence. Okay? What else? So when it says t of n and then they have t of n minus 1, what that means is that the next term is the previous term plus a constant. So what this pretty much means is, alright, let's take this sequence right here. My first term, t of 1, is 1. T of 2 is 2. So what that means is t of 2 is equal to t of 1 plus your common difference, which is 1 in this case here. Now, is that not true? See, t of 2 is 2, t of 1 is 1, plus 1. Does that not equal 2? It does. So what this is saying is, alright, in order to work out my next term, I need the previous term added with your common difference. So your common difference is how much you're increasing or decreasing in your arithmetic sequence. Hopefully that makes sense. So if you see it written like this, that's pretty much what it means. It means the next term in your sequence is your previous term plus your difference. So the reason why they have n minus 1 is because, alright, if n was 5, n minus 1 would be 4, which is the term beforehand, if that makes sense. So that's why they have it written like that. It's a more general mathematical expression for it. And yeah, they have an arithmetic sequence here, and we can see it's increasing by +3. So all you got to do is pretty much, alright, work out how much it's increasing by. Now the way you can do that is pretty much just look at the sequence and look at the terms. So if they tell you it's an arithmetic sequence, just take, alright, how much have I increased or decreased pretty much. So all you got to do is take your first, the term ahead and subtract the second term. Not the second term, the term previous to it. And that will give you your common difference if you wanted to work that out. But you can pretty much tell straight away from that. Right, let's move on to this page here. So this is the general formula for an arithmetic sequence. So t of n is your first term plus n minus 1 times your d. Okay? Now, you can actually update this formula if you wanted to. You can write it like this. T of n is t of k plus n minus k of d. What I've done is pretty much, alright, instead of having 1 here and here, I can just replace that with any number. As long as t of k, actually this is going to be a bit confusing because I use t of k here. Let's use a different letter pretty much. Let's say Q, they don't use Q, awesome. So T of Q, okay? And say there's Q here. And this is still N. As long as T of Q is before T of N, okay? So what that pretty much means is you don't need your first term. And you'll understand why when you have a previous problem, when you get given two terms that aren't your first term and you're asked to find like the second term. So that's your general formula you'll see in your syllabus. They can write it like this. So all they're doing is replacing T of 1 with A pretty much. Let's read what they have here. So the nth term of an arithmetic sequence is given by this. That's pretty obvious. D is your common difference between two successive terms. That is that D is T of K minus T of 1. So that pretty much says is, alright, the term, like let's say we had this arithmetic sequence where we had 3 and 5. It's increasing by 2. This is your term here, and this is your term here, because T of K is the term after T of K minus 1. In other words, this term is before this one successively. So for example, let's say this was 1. So T of 1 is 3. Actually, no, sorry. T of 1 is 3. That would mean, actually, let's label that. Let's say, alright, this is T of 2. T of 2 is 5. And then T of 1 would be 3. And that matches up as well, because if we label that, alright, that's K, and that's K minus 1, we can see that if 2 was K, that would mean if we put 2 in here, minus 1, that would give you 1, if that makes sense. So this means the term beforehand pretty much, okay? And they can written it like this. I don't really like how they go very mathematical with this, but if you are interested in that, that's what that pretty much means. But let's get straight into some questions pretty much, because the best way to practice this is to pretty much understand patterns and certain questions of it. So let's take a look at an example question. So, example 9, find the 10th term of the arithmetic sequence -4, -1, 2, and 5. Okay, so to start off with, we pretty much label our terms. That's your first term, so that's your T of 1. And let's just write out the formula straight away. So T of n equals T of 1 plus n minus 1 times by d. Okay? Now, we've got T of 1. T of 1 is 4. Tick. We want to work out d, which is our common difference. So how much, now we can see we're increasing, because we're going from negative to a smaller negative. So going from here to here, and we can see it's increased by plus 3. And it also works with here as well, plus 3. So your d is 3. So let's see what we have. So T of n is equal to pretty much the first term, which is 4, plus n minus 1 times by 3. Okay? Now we're asking for the 10th term. So that means we're looking for when n equals 10 pretty much. So if you want the 10th term, you substitute 10 into your little rule here, because you see we've actually got a little formula here. So if I rewrote it like this, T of n is 4, and we distribute the 3 plus 3n minus 3. This is our little rule here. So we have 3n plus 1. So if you put in, alright, n equals 1, you'll get your first term. So for example, T of 1 is going to be 3 times by 1 plus 1. Did we do that right? Oh, that's -4. That makes sense. -4, so that will be minus 7. I was wondering why we were going to get positive there. Nearly made a mistake. So that's -4. No, -4, -7. So that's our rule there. So if we get our first term, so if we put in n equals 1, we should get -4. So we're going to have 3 times by 1 minus 7. So T of 1 is going to be 3 minus 7, which is -4. So boom, our rule works. So that means if I put in n equals 10, I'll get the 10th term, even though I don't know what it is because it's all the way up here. Because all we have is, alright, you got your second term, your third term, and your fourth term. Now you can keep adding if you wanted to, but what if they asked for like the 100th term? Then you wouldn't want to do that. You want to save time. So all you're going to do is plug into your formula. So you're going to substitute this guy wherever the n is pretty much in your rule. So you're going to have T of 10 equals 3 times by 10 minus 7. So you get, in other words, you're going to have 30 minus 7, which is going to give you 23. So that will be your 10th term in your arithmetic sequence. Hopefully that question there makes sense. If you have any questions, leave some in the comments and I'll try my best to answer them. But let's move on to another example. So, example 10. If 41 is the nth term in arithmetic sequence given by this, find the value of n. So, what we're asking is, alright, what term is this? Is this like t of like 31 or t of like 41? So where it is in your sequence pretty much. Now it probably won't be one of these ones. I've just chosen them as just obscure examples pretty much. But that's pretty much the question we're asking when they're asking for the nth term. We're trying to work out where it is in our list. We know this is the first term, so this is your t of 1. And we know that's your second term. We want to know where the 41 fits in our pattern here. Now it's quite large, so it's going to be all the way over here pretty much. So this is what we do. We write out our little rule at the start. So straight off the back, you look for the word, alright, arithmetic sequence. I can use this rule. So t of n equals t of 1 plus n minus 1 times by d. And let's see what we have straight away. So our first term, t of 1, is minus 4. Let's work out our difference. We've increased by plus 3 again. Now, is actually that the same sequence? Yes, it is. So we got given the same sequence. So t of 1 is minus 4. And then we don't need another term. We need our difference. Our difference is going to be positive 3. So we go t of n equals minus 4 plus n minus 1 times by 3. We're going to get t of n equals 3n minus 7. So that's our general rule here. So now, we are looking for an n. We're not looking for a term. We are looking pretty much, because we've got the term, we're looking for pretty much where it fits in. So, what we're going to do is, alright, 41 is my t of n term. So if I put the 41 here, I can solve for n pretty much if I wanted to. So what we're going to do is just do that. So 41 equals 3n minus 7. So if I solve this, it will tell me my nth term in this sequence pretty much. So all I'm going to do is move the 7 to the other side, so you get 48 equals 3n. And then what you're going to do is divide both sides by 3 pretty much. So 48 divided by 3 is going to be 16. So that means 41 is the 16th term. So in other words, t of 16 is 41. So that's how you answer that question there. If you have any questions, leave some in the comments and I'll try my best to answer them. But let's move on to another example so you can see this in a bit more detail. Okay, so the 12th term of an arithmetic sequence is 9 and the 25th term is 100. Find a and d and hence find the 8th term. So remember, if we go back to this slide here, this is another way they can write the rule, written like this. So in other words, a is your first term, okay? And we already know what d is. D is our common difference. So this is your first term. And d is your common difference. So what have we been given? We haven't been given like a pattern like before. We've been given two pretty much terms of our sequence. So you've been given, alright, the 12th term, t of 12, is 9. And you've been given the 25th term, so t of 25 is 100. Okay, so this is where you couldn't really be counting between the two now. So we are asked to find this and the 8th term. So 8th term. So we write out our general rule. So t of n equals t of 1 plus n minus 1 of d, okay? So, let's see what we can do. At the moment, we can't really do much, but what we can do is, remember, we can actually replace this with any number we want. It doesn't have to be 1, as long as this term is smaller than your t of n. So in other words, we can use this rule here. T of n equals t of, we'll go q, plus n minus q and d. So all I've done is replace the 1 with q, okay? But t of q must be a term before t of n. Okay? Just keep that in mind. So in other words, if we're going to use this information, this term here is before t of 25, which makes sense. Now it doesn't matter what sign it is, it matters what term it is. So for example, if we had this previous term, even though negative negative 4 here is smaller than 2, it becomes beforehand. So it matters what term it is in the sequence, not the sign of the number. So what we're going to do here is, alright, let's just substitute this information and this information into this equation here. So in other words, let's rewrite it. So all I'm going to do is wherever there's an n, I'm going to replace with a 25. So I'll rewrite it like t of 25 equals t, and now wherever there's a q, I'm going to replace it with a 12. So t of 12 plus, and then you put the 25 here, minus the 12 of d. Now, we know what that number is. It's 100. So we go 100 equals, and we know what t of 12 is, it's 9, plus 25. 25 minus 12 is going to be 13, so we can get rid of that bracket and write a 13d. And now we've got a very easy equation to solve for our common difference. So now we rub this out because I need a bit of room. So 100 minus 9 gives you 13d. So 100 minus 9 is going to be 91 equals 13d. Divide both sides by 13. So 91 divided by 13, I'll use my calculator for that one because I don't know what that is 7. Okay, so common difference is 7. So we found that one straight away. Okay? Alright, now let's get rid of all this because I need room pretty much to continue the questions. Righto, so using our rule, we had t of n equals t of, I don't know what letter we use, q, plus n minus q of d. We know what d is now, so if you wanted to, you could go back to using 1 here, because that's what we've got to find next. So you can replace that back with a 1, and then substitute your d. Actually, let's not use that color. Your d will go there now. So that's 7. So you're going to have t of n equals t of 1 plus n minus 1 times by 7. Now I can use either term because t of 12 and t of 25 are greater terms than t of 1. So now we can find t of 1 by substituting either term. So we'll go t of 12. So t of 12 equals t of 1 plus, and now wherever there's an n, you replace with a 12, minus 1 times 7. And we know what t of 12 is. T of 12 is 9. So we have 9 equals t of 1. And this is going to be plus 77. So t of 1 is going to be a very, very small term. So if we go, t of 1 is going to be 9 minus 77, which is going to be negative 68. Now, that is actually kind of what I was expecting because your 12th term is only 9. So it makes sense that we have a very, very small number at the start because it's starting from here and it's increasing by 7. So after 12, if you go 12 times by 7, that's going to give you pretty much your 9th term, your 12th term, which is 9. So now we know the first term is negative 68. Okay. Now we can rub that out because we found everything so far. And now we've got to answer the final question because we've got to find the 8th term. So using our rule again, t of n equals t of 1 plus n minus 1 times by d. We know what d is, and we know what the first term is. So your t of n is equal negative 68 plus n minus 1 times by 7. So in other words, t of n is going to be 7n minus 68 minus 7. So 68 plus 7 is going to be 75. So you can have t of n is equal to 7n minus 75. So that's your general rule. So if you put in n equals 8, you can find your 8th term. So t of 8 is going to be 7 times by 8 minus 75. So t of 8, 7 times by 8 is 56 minus 75. Okay. Now you could have worked this out with the stuff we have here because your 8th term is only 4 behind this term here. So if you wanted to, you could go, alright, 4 times 7 minus 9, and that would give you your 8th term as well. So your 8th term is going to be 56 minus 75, I believe is minus 19, and that's it. Too easy. Alright, so we found every single term here. If you have any questions about this, leave some in the comments below, and I'll try my best to answer them. Anyway, let's move on to the next example pretty much. So, if we take a look at a more practical example actually now. So, a national park has a series of hunts along one of its mountain trails. The first hunt is 5 kilometers from the start of the trail. The second is 8 kilometers from the start of the trail, and the third is 11 kilometers, and so on. Now, they haven't said it's an arithmetic sequence, but we can tell it's an arithmetic sequence because if you look at the distance between the trails, so the first trail is 5 kilometers, but the distance between the first and the second is 3 kilometers. And so is the distance between the second and the third, that is also 3 kilometers. So we can see it's an arithmetic sequence at the start. So for this question, you would assume it's an arithmetic sequence. So how far from the start of the trail is the 6th hunt? In other words, the first term is 5. The second term is 8, and the third term is 11, and they're asking for the 6th term. Okay, so we can imagine it looks like this: 5, 8, 11, so on and so forth. So T of n equals T of 1 plus n minus 1 times by d. So you substitute your first term, which is 5, plus n minus 1 times by d. So our d is 3. We know what that is. D is 3. So we can actually substitute that in as well. So T of n equals 3n minus 3 plus 5. So T of n is 3n plus 2. Okay, so that's our general rule. So if you want the 6th term, you plug in 6. 3 times by 6 plus 2 is going to be 20, I believe. Because, yeah, 3 times by 6 is 18 plus 2. Yep, that's 20. Right, so it will be 20 kilometers from the start. Okay. Now, the second question is, how far is the 6th hunt from the 12th hunt per month? So it's pretty much a distance thing. So we've got to work out the 12th term, and we've got to work out how much distance is between these two terms. So using our rule again, you plug in the 12. 3 times by 12 plus by 2. So that's going to give you, I believe, 38. Yep. So the 12th term, or 12th hunt, is 38 kilometers from the start. So if that's 38 kilometers from the start and that's 20 kilometers from the start, you go 38 minus 20, and that'll give you the distance between the two of them, which is 18 kilometers. So the answer to B isn't the 12th term, it's the distance, because it's how far it is. So you would put 18 kilometers. Okay? Right. Those are all the general examples I've taken from this book. I'm going to do a part 2 where we're going through the rest of these guys, which are actual questions. But if you have any questions so far about this topic, leave some in the comments and I'll try my best to answer them. But yeah, this is Introduction to Arithmetic Sequences.